I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 30th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and smash the like and subscribe button. Ring the bell. You get automatic notification when the videos are posted, typically on Sunday afternoons. And if you have a question, write it in the comments section. We'll be happy to reply and help clear up anything you may not understand. All right, let's get to work. We'll start by looking at significant wave heights in the North Pacific Ocean, and clearly we have a storm producing 41-foot seas pushing into the central Canadian coast with energy starting to radiate southeast towards the California and Pacific Northwest coast. Swell is on the way. We'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet. We see that here. It's not much of a dip, but it's just enough. And that helps create a counterclockwise flow aloft and also at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough to get traction on the ocean surface, start generating seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. So we have a little trough here in the northern Gulf of Alaska that we saw from the previous image is generating seas and swell, and you know what comes from that. But over in the west, the more important area, the jet is split. When you have a split jet stream flow, and let's get organized here. Kamchatka, Kuril Islands, North Japan, and this split is like over Asia and the Kuril Islands. That creates high pressure in between the two flows, and that's not what we want to see, especially this time of year. So split flow in the west, consolidated flow in the east, trough in the east, and in the west, high pressure. So kind of not what we really want, but any little thing like the trough up here, we'll take it. All right, let's put this into motion. So we get into Monday, the trough actually deepens some more, starts pushing more like one of these classic backdoor fronts down the California coast, pretty typical for La Nina. So more of a weather producer than a swell producer, because you see the jet is heavily ridging to the north over the Gulf of Alaska. This is into Tuesday, November 1st, but maybe a hope for some weather pushing down the coast. And then the jet also starts trying to push off to the west off Japan. The first time it's done that this year, setting up maybe a bit of a trough here and maybe some hope for gale development. That trough continues as we get into Wednesday while the ridge starts building into California. And typically when you get this kind of ridging pattern, that's strong northwest winds. Not great, even if there is swell in the water, it's just a choppy mess. So the trough in the west makes it fairly far off to the east, but then you see the jet starting to split here on late Thursday or early Friday, November 4th, and that probably will stop any gale production in that area. You need these winds here to be in the bottom of the trough, and that's not what's happening. Instead, you get this giant split pushing up into the Bering Sea. Most of the wind energy actually takes off up into the northern branch of the jet, just doesn't do anything. But also notice on Saturday here, winds start building to 200 knots supposedly over the northern Gulf of Alaska. This is the only real area we've had recently for gale development. It looks like it's going to do it again on Saturday, and then falling south into Sunday, the 6th of November. Again, a backdoor trough, it looks like, and we're a week out, 180 hours, don't believe, but this is really the ultimate in backdoor troughs with a good amount of wind energy feeding it, likely supporting some sort of weather production for British Columbia and likely down into the Pacific Northwest. Some of the models, this one doesn't show it because it just doesn't go out that far, but some of the models suggest this is going to reach down into the Sierra and maybe be another weather producer. That would be good. In the west, the jet trying to get its act together. It needs a little help from the MJO, and it needs a lot less destructive interference from La Nina. So let's go take a look down at the surface. Surface level wind, surface level pressure, 12Z run on the model today, the 30th of October. We see our little gale up here in the northern Gulf, and it starts fading out. Now, we know there is some sort of trough building in the West Pacific. Sure enough, a gale develops, but notice the fetch is not completely wrapping around the south quadrant of this gale. It's mainly over here in, what would this be, the northwest quadrant, producing north winds, pushing south. Hawaii's right here. So fetch not really aimed at the Hawaiian Islands. That gale, whatever you want to call it, kind of keeps doing the same thing into Wednesday. And if anything, the fetch gets more aimed off to the west than to the south. Maybe some sideband swell for Hawaii, but we know that there is some sort of a big ridge going on here, and sure enough, here's your high pressure 1032 millibar over the Gulf of Alaska as we get into Thursday the 3rd. And then another gale starts developing on Friday, November 4th, and we see 35-knot winds pushing towards the Pacific Northwest. Now, you see a gale here off Kamchatka, but all the fetch is really in the southern quadrant, pushing over the far west Aleutian Islands into Kamchatka. That ain't going to do anything. And this other gale here, all the winds are east winds aimed back at Japan, not at Hawaii. Maybe a little bit of 30-knot fetch here aimed at Hawaii, so we'll give it a little hope for something. Anyway, we get down. 30-knot winds continue in late Saturday into Sunday, pushing down the California coast. And there we are, 180 hours out. Still some fetch. This looks like more of a weather producer than a swell producer, but we'll find out more in just a second. So significant wave heights, the effect of these winds on the ocean surface. We're going back in time to February, October 26th. Little gale developed here in the northern Gulf, produced some seas. Here you go, 26, 27, 28.1 feet. Way up at 54 north, 153 west. That's like on the 315-degree path into Northern California and Central California, even a little bit steeper. And relative to Southern California, almost no energy from that steep an angle can make the wrap in, except maybe down the most extreme southern end of San Diego. Anyway, this system, this was Thursday, the 27th of October, produced, again, 26-foot seas. And you could see swell or raw sea energy pushing south. This swell hit California on Saturday. There were definitely some double overhead waves in the San Francisco Bay Area, and a little bit of decent wind opportunity as well. So that was a start of fall. But of more interest, starting on Saturday, early morning before sunrise, another gale developed in the far northwest Pacific, northwest Gulf of Alaska, with 37.9-foot seas, building to about 38 feet, pushing through the Gulf through Saturday, fading a little bit, and then building again early Sunday morning with up to 41-foot seas, building to almost 42 feet on Sunday morning. Swell from this system is pushing down the coast, bound into California, sometime late Monday, Central California, early Tuesday sort of thing. And again, the real steep angle going to be problematic for Southern California. Let's also go back and take a look at this. So Hawaii, relative to Hawaii is about 157 west. The system did try to get organized almost due north of Hawaii. The winds were out of the west, aimed this direction, not very much to the south. Maybe some very limited sideband swell will make it into the Hawaiian Islands, but nothing too significant. So now we look at the forecast. Looking forward, we're into Sunday afternoon, and that gale pretty much fades out. We know there's something forecast for the western northwestern Pacific, 26-foot seas, 27-foot seas, 28-foot seas. That's about it. Mostly all aimed due off to the south. Hawaii's here. Maybe a little bit of energy to make it to the Hawaiian Islands. But generally, we kind of been looking at this, and by size-wise, we're talking pretty small. Nothing like even head-high sort of thing. All right, so we get into Friday. We know there's another gale forecast for the northern Gulf into late Friday night, Saturday. 26-foot seas develop while that cutoff gale, or whatever you want to call it, tries to organize again. But again, not aimed at all at the Hawaiian Islands. That gale continues in the Gulf, falling south, off the Pacific Northwest with 21-foot seas on Sunday, November 6th. So again, another dose of rather large but rather raw, we'll call it proto-swell, pushing into the Pacific Northwest and down into North and Central California. Now looking down south on Wednesday, a tiny weak little gale developed southeast of New Zealand with, well, we see about 26-foot seas there southeast of New Zealand getting into Thursday. Yeah, about 26 feet. That was about all it had to offer. It pulsed again with another pulse of 26-foot seas on Friday into early Saturday, and then started fading out from there. Swell is in the water. A lot of this just barely sideband energy pushing into Hawaii, nothing large at all. And swell expected into California. I think it's for the weekend. Not that would be this coming weekend. So what's that, like the 4th or 5th of November sort of thing. And mainly focused on Southern California. Not that it's really focused there, but there'll be a lot of north wind swell and bump and swell up in north of Point Conception. So you probably never see the Southern hemiswell. But Southern California, its protected breaks will probably pick up the swell. Could be fun. Nothing huge, but certainly rideable. And this is probably the last season of or the last swell of the year from the South Pacific. Looking forward, we're just running through the model here, looking for any sign of, we'll say, 26-foot seas aimed off to the northeast. Yes, here's a little area of 30-something foot seas, but they're all just pushing right into the Ross Ice Shelf here in Antarctica. No hope for any swell. We're already out into Friday and now Saturday, the 5th of November, and really nothing there. So we said the last swell of the season. We meant the last southern hemi swell of the season. That's probably it. After that, the focus is going to be entirely to the north. All right, now wind forecast. We're looking here the Gulf of Alaska, Pacific Northwest, California, Hawaii here. High pressure in control for the moment. Supposedly northwest winds at 20 knots off the California coast. The buoys support that, but near shore in San Francisco, it's been pretty much dead wind and fog. Pea soup fog. You can't hardly even see the surf. It's been that way all day. So not particularly a great surf day. We get into Monday. Northwest winds continue 15, maybe 20 knots south of Monterey Bay. Modest trades for the Hawaiian Islands. Tuesday, the winds lighten up, but there's a front. You can see it right here. Light wind pattern more or less south of the front first thing in the morning. Northwest winds behind the front. The front over Cape Mendocino. Again, early Tuesday, quickly pushing south, 15-knot plus winds probably along the California coast as we get through the day. Trades for the Hawaiian Islands. On Wednesday, the 2nd of November, northwest winds, not so bad according to this, looks like 10 knots, but the local models suggest maybe a little bit higher. On Thursday, the 3rd of November, same sort of deal, 15, maybe 20-knot winds, Point Conception out of the northwest. Trades, high pressure builds, trades pick up for the Hawaiian Islands at 20 knots. Friday, again, strong trades, 20-plus knots, with a lighter wind pattern, theoretically, for the California coast. So we get into Saturday, again, light northwest winds, California coast, trades in control for Hawaii at 20 knots. And then as we get into Sunday, November 6th, here it looks like another front pushing down the coast. Trades continue for Hawaii, and there we are, out a week. So the issue is, the storms are all local relative to California. We really want them more out here, 1,000 miles away from California, the Pacific Northwest, and further north of Hawaii, with fetch aimed more to the southeast, and we're not seeing any of that. So we're just taking what we can get right now and trying to make the most of it. Precipitation forecast for California, right there. We are today, Sunday, high and dry, high pressure in control. Here comes the front pushing down the coast on Tuesday morning. Rain and snow at higher elevations for Cape Mendocino. Early in the morning, pushing south. Pretty good amount of snow, looks like, for Tahoe. The models have been on again, off again regarding the exact strength of this storm. At 1 point snow forecast, we're up to 2 feet for Tahoe. We'll take a look at that in a minute, but it looks like maybe some rain. It's hard to say exactly. Let's actually go look at this one more time. Looks like rain down to maybe Big Sur, something like that, about midday Tuesday. Again, snow for the Sierra. By Wednesday, things start breaking up, pretty dry, and that's pretty much the end of that system. But then another system is forecast behind that, building, dumping good precipitation over the Pacific Northwest and trying to make it south. This model only goes out a week, but we have another one that goes out 10 days, and we're going to take a look there in just a second. The snow forecast dashboard for Squaw Valley. So right here, this is the projected snow from Tuesday's system. Looks like, well, actually, we can click this thing. Let's see where we go. There we go. Snowfall amount, 9.9, 10 inches into Wednesday. And then if we go back, out past the 1 week window, maybe another foot or more of snow forecast out around November 9th, 8th, something like that. Do I believe any of that? No, way too far out on the models. This even we're having a hard time with. We'll get to see what really happens. There's been disagreements between the GFS model and the European model, but hopefully it's starting to stabilize, and hopefully we do get, close to a foot of snow up in the Sierra. That would be a great start for our Halloween season. Looking at freezing levels. So today, freezing level, the whites and blues here, that's freezing temperatures. The gray is sleet. The red is full liquid precipitation. Right about, we'll say 12,500 feet. But that freezing level this is for Squaw Valley, Palisades, Tahoe. This is the base of Squaw. This is the top of Squaw at about 9,000 feet. The base about 6,200 feet. See the freezing level going well below the base down to, what's that, about 2,200 feet theoretically at some point on late on the 2nd and into the 3rd, sort of thing like that. Then a big warm-up after that. That'll just sort of solidify whatever snow we get into a nice solid block of blob. And then that happens on the 5th. And then temperatures start easing their way back down again. The yellow line here, yellow lines are snow. They don't really correlate to anything in particular, just say potential for snow. And same thing here, but the freezing level, again, falling back below the base, supposedly by November 7th. So if this verifies, that would be a nice start to the season. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? These are our long-term oscillations. The MJO, about a 6-week type oscillation over the Pacific, and of course El Nino or La Nina being a multi-year oscillation. We start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. There are two phases, active and inactive phase. The active phase is the good one, the inactive one, the bad one. Active phase is effectively a low pressure system. The active phase and the inactive phase rotate around the planet from west to east on the equator. Active phase on one side of the planet, inactive phase on the other. It is the active phase when it moves over the West Pacific, it being a low pressure system, it creates clouds, but it also takes warmer air down at the ocean surface, starts lifting it up into the atmosphere. That feeds energy to the jet stream. The jet stream, the stronger it is, the better it is at producing troughs, which therefore support gales, which support wind, and which support storm production. Also, the active phase of the MJO, when in the West Pacific, we call it the Kelvin wave generation area, can reverse trade winds in that area, take warm water that's in the West Pacific, and start pushing it off to the east, not on the equator, but underneath the equator. A ball of warm water that's known as a Kelvin wave takes about 3 months to make the journey from the West Pacific to the East Pacific. When it does, it'll erupt around Ecuador and the Galapagos, warming water temperatures there. If you have successive active phases of the MJO that create successive Kelvin waves, that can significantly warm water off of Ecuador, and that can help usher in El Nino. All right, so we're very interested in the active phase because, 1, it feeds the jet stream. 2, it also creates Kelvin waves that can help push us long-term into an environment more favorable for storm production. All right, so we're looking at winds across the Pacific. West Pacific here, East Pacific here, the equator here, This is New Guinea here. Kelvin wave generation area runs from the far west Pacific to the date lines right there, just west of the date line, about 170 west, 5 degrees north and south of the equator, so draw a box in your mind right there. And when the active phase is in this area, see these arrows? This is trade winds. This is data from the Tahoe buoy race, series of buoys strung across the equator used for monitoring El Nino, but they have wind sensors on them. These are 5-day average winds. The longer the arrow, the bigger it is, the stronger the winds. So east winds in the East Pacific, east winds pretty strong over the Central Pacific, same thing in the Kelvin wave generation area. Doesn't look like a whole lot good going on there, but it's not the actual wind speeds. It's the anomalies, the difference from normal for this time of year. And these arrows suggest, well, the trades are just a slight bit stronger in the East Pacific, modestly stronger over the Central Pacific, and about the same thing over the Kelvin wave generation area. So no sign of the active phase of the MJO. If anything, maybe a weak inactive phase. So we take a look at the forecast going out 1 week. Zonal wind anomalies, 850 millibar zonal wind anomalies. These are about 4,700 feet, but a good proxy for what's going on down at the ocean surface. This is the whole planet on one chart. The date line runs right up the middle here. Kelvin wave generation area, the far west Pacific, well, it starts about 135 east, so right there. And this is the forecast down here. This is what's been happening in the past. The blues, easterly anomalies, okay? This is the inactive phase of the MJO. The oranges and the yellows, westerly anomalies, the active phase. It looks like there is no MJO, that the active phase has been locked over the maritime continent. That'd be right about here. That's like Bali in that area for, well, at least the duration of this chart, and the reality is it's been that way for about 2 years now. East anomalies over the date line. This is the classic La Nina signal. High pressure, stronger than normal trades over the date line region, with all the west anomalies, the good stuff we want in the Pacific, pushed over into the Indian Ocean. Looking a week out in the Kelvin wave generation area, the good news is here, the easterly anomalies appear to be weakening, and a little bit of westerly anomalies are forecast in a couple of days, building some over the date line, and not necessarily even driven by what appears to be any major MJO push, but nonetheless, the weakening of the easterly trades is exactly what the models were suggesting months ago, and it appears it is starting to happen. In fact, even starting about the 20th of October, we got a little push of westerly anomalies here. That was probably the active phase of the MJO, pushing from west to east across the equator, and then maybe something else going on here in a minute. Let's keep digging. So we're going to now look at going out 2 weeks, looking for the presence of westerly anomalies. This is data from the GFS model, down 925 millibars, a little bit closer to the surface. Let's get ourselves oriented here. The equator right here, Central America down here, and Mexico there, Hawaii up in there. Kelvin wave generation area, 5 degrees north and south of the equator, out to about 170 west. So this is the area right here we're most interested in. And today, weak westerly anomalies trying to get organized right around the date line, just like what we saw before. That continues. Easterly anomalies, if anything, getting lighter. Some sort of westerly anomalies trying to hold in the dateline region, if not building into November 5th. Not huge or anything, but a little bit. And even stronger as we get into November 7th. Then they start breaking up again. Easterly anomalies, the purples and blues are easterly anomalies, the oranges and reds westerly anomalies. But notice these big area westerly anomalies on the equator in the East Pacific. Eastern anomalies come back for a little bit, then they weaken some. Westerly anomalies not fully building in, but easterly anomalies fading as we get into November 15th. And then looking out 2 weeks, we're looking at outgoing long-wave radiation. That's cloud cover, basically. The blues, more clouds than normal. The reds and yellows, less clouds than normal. This would be the active phase of the MJO. This would be the inactive phase of the MJO. The equator right here. South America, Central America, Hawaii, New Guinea. Kelvin wave generation area right in here. So this is the statistic model. This looks like the active phase of the MJO today, going out about 5 days, and then just falling into a neutral pattern. That per the statistic model, the dynamic model suggesting the exact same thing. Phase diagrams, another way to look at the same two models, statistic model here, dynamic model here. The MJO moves from west to east, from the Indian Ocean over the maritime continent, over the West Pacific to the East Pacific, across the Atlantic, over North Africa, back to the Indian Ocean. It goes round and round, both active and inactive phase. This chart charts the active phase. Where the heavy dot is where the active phase is. So it's in the West Pacific, exactly where we want it. The further the dot is away from this circle, the heavy dot there, the stronger the active phase is. So a modest active phase, forecast to make it somewhere to maybe the Indian Ocean or the probably the Eastern Atlantic 2 weeks from now, and very weak. For the statistic model, dynamic model says, if anything, the active phase getting stronger over the next 2 or 3 days, then sort of zipping off to the East Pacific, then crashing and making a turn and back over the maritime continent, almost the far West Pacific 2 weeks from now. So not bad, but we really want to see these dots all clustered up here in the high end of the chart. When you do that, then you know you've got a strong active phase of the MJO forecast. Here's the upper level model. This goes out 40 days. This shows areas favorable for precipitation. So South America there, Central America, New Guinea there, Kelvin wave, dateline, the equator right there. Dateline roughly right there. Kelvin wave generation area right here. The greens area is favorable for precipitation. Someone would call that the active phase of the MJO. Each panel is 5 days. It goes out 40 days. So you see the active phase making its way across the Pacific from today into about, November 24th. So about Thanksgiving, something like that. Then the inactive phase of the MJO starts making its way, enters into the West Pacific about mid-November, makes it across the Pacific to about, December 9th, something like that, and then a weak active phase forecast behind that. Here's the CFS model. This goes out a month, 30 days. Past performance down here. This is, again, 850 millibars, zonal wind anomalies, the blues, easterly anomalies. One could say that's the inactive phase of the MJO. Reds, the westerly anomalies, active phases of the MJO, but we get more detail here. The dotted contour is the actual inactive phase of the MJO. The solid contour, the active phase. You notice all these, they make it to just to the West Pacific, and they all fall apart. They hit this impenetrable block of high pressure over the dateline, and they all dissipate. But look at this. October 29th, yesterday, active phase of the MJO started developing, forecast pushing over the dateline for the next week and a half, almost 2 weeks, with westerly anomalies forecast building on the dateline and the whole way from the West Pacific, the whole way across the Kelvin wave generation area and almost to a point south of Hawaii. That's pretty good. Now, it's not long lasting, barely, not even a week, and then easterly anomalies develop behind that. But the interesting thing is, after that, once you get to about November 15th, 17th, something like that, easterly anomalies start significantly weakening, and even with the inactive phase of the MJO in control, you see the white, that's dead neutral winds. They continue over the West Pacific. So once this active phase pushes through, dead neutral anomalies, not east anomalies, make it filling halfway of the Kelvin wave generation area. And this is the most conservative rendering of the CFS model that we've seen. We've kind of been questioning it. But even this is suggesting half the Kelvin wave generation area is going to be in neutral wind anomalies for at least 2 weeks after November 12th. And if anything, you can see westerly anomalies building into almost halfway across the Kelvin wave generation. We'll say 33%, a third, and holding in some fashion through November. This is very good news and not unexpected because the models have been suggesting some flavor of this for quite a long time. All right, so here's the CFS model going out 3 months. Past performance is down here. The forecast is up here. The blues are easterly anomalies. The yellows, westerly anomalies. You can see, and the date line runs right up the middle. Kelvin wave generation area starts right about here, the whole way up the chart, and goes to about here. The real teller here is, look at this development of westerly anomalies. The yellows are westerly anomalies. In fact, here we are, the development of a little bit of westerly anomalies today in the far west Kelvin wave generation area. Here's that little finger, that like Kelvin, this active phase of the MJO that's forecast about a week from now. And you can see this line right here of where the easterly anomalies start. They are completely out of the Kelvin wave generation area by November 17th, something like that. They try to make a little comeback here in the early part of December, and then they get completely squashed as westerly anomalies start building in earnest the whole way across the Kelvin wave generation area again as we get into January, and stronger beyond that. Wow, now this is even better. Easterly anomalies that were right here filling the whole West Pacific are relegated to, well, they make a little comeback here in December, but then only over the far East Pacific, almost inland of well, it would be the equivalent of being inland of California, but this is on the equator, while westerly anomalies fill the Pacific. Let's overlay the MJO, see if we can get a sense of what's going on. Solid contour is the active phase of the MJO. Active phase is pushing across the Kelvin wave generation area as we speak, with a second lobe of it forecast to continue through about November 18th, something like that. Then the inactive phase develops beyond that week, and even with that, westerly anomalies prevail, and they just keep on going, keep on building, get a stronger, a firmer grasp over not only the Kelvin wave generation area, but maybe a good part of the Pacific as we get into the early part of January. So what's going on? We'll overlay the low pass filter here. This is a high and low pressure bias. Today, the dotted contour here, this is the La Nina signal. High pressure in control. But notice the second and two contour lines. The second contour line forecast to die now by December 1st. The primary contour line, now last week I think it was dying out in like January 10th. Now it says, well, maybe it'll linger for a little bit, but it's effectively out of the Kelvin wave generation area as we get into the second week of January. The low pressure bias, the El Nino indicator, if you will, over the maritime continent, but slowly easing its way into the Pacific, making it to, I did this more detailed earlier, about 155 east, filling half the Kelvin wave generation area as we get into January. And this is later January, and the expectation is beyond that, it will continue to move even further to the east. So the models, compared to last week, compared to 2 weeks and 3 weeks before that, the westerly anomalies were a little bit stronger. This easterly anomaly, little bump right here, didn't exist. But again, tomorrow, that could all change on the models. Still, the trend is the same. If anything, it's looking a little bit better right in the immediate near term here with westerly anomalies. As we get into 2 weeks from now, westerly anomalies effectively gone from the Kelvin wave generation area, never to return in the near time future. And we're getting greedy here, and we're hoping the easterly anomalies completely exit the Pacific Ocean as we get into January. This is, we're hoping, a worst-case scenario, but not too bad. So atmospherically, the forecast looks really quite good. We look like we're moving in the right direction. What the models were saying months ago is what they're still saying, so that is good news. But that is a forecast, that's the atmosphere, that's the start of a long process. We have a big train that we have to move to get to a place where we really want to be. The ocean is what I'm talking about. Temperatures in the ocean will start down low and will work our way to the surface. Data from the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. West Pacific here, East Pacific here. This is temperatures down in the ocean. These little lines and X's here, these are the anchor lines on the buoys themselves in the far West Pacific. Far East Pacific over here. The X's are the sensors on those anchor lines. The sensors collect data, radio it up to a central processing facility, use a model to fill in the gaps. Notice there's big gaps here from, like, what's this, 155 to 140, so what's that? It's like 900 miles between each set of anchor lines. So at best, it's a rough approximation for what's going on, but you get the idea. So this is the 28-degree isotherm line here. That's 28 degrees centigrade. That's warm water at about 175 east. It was actually back last week about 172. So warm water making a little eastward progress. We want to see it fill the whole way in here, but we're not expecting that right now. The 26-degree isotherm, about 159 west. I think that's where it was last week. The 24-degree isotherm, well, it was at 120 and even 117 a couple of weeks ago. Backtracking, easterly trades, probably La Nina's last stand, having its effect on the ocean, creating more upwelling. But it's not the actual temperatures. Again, it's the anomalies, differences from normal for this time of year. You see +3, +2, +1 degree centigrade. That's like 5, 6 degree above normal temperatures in the West Pacific. And then 1, 2, 3 degree equal amount of cold water in the East Pacific here down. Where is that? That's about 130, 135 west, something like that. The dividing line between the two is right about, well, this is 155 west, so Hawaii is like right here. So south of Hawaii, more or less, is the dividing line. Warm there, cold there. The warm wants to push its way off to the east, but it has to have the active phase of the MJO and westerly anomalies. That's winds blowing in like that direction to give this some momentum to come in, take this cold water, squeeze it off to the surface, and have it all drain out so that this warm water can start pushing its way across the Pacific. Another model, a little bit higher fidelity, showing the same basic picture, but temperatures much warmer than forecast in the previous model over in the west, and much colder than forecast in the east, with a dividing line roughly 155 west, literally a brick wall. And what separates this is east winds here and not enough west winds here. As soon as the west winds pick up, we saw it on the previous chart. So this is the atmosphere forcing the ocean to move from a La Nina, a cold water base state. Notice there's cold water even up to the surface here. Get this cold water out of here and get a warm water flow. Take warm water that's in the Indian Ocean, the maritime continent area, start having it push across the Pacific, and all of a sudden the atmosphere will then start feeding off of that warm water, and the atmosphere and the ocean become locked together, coupled they call it, and then you turn into an El Nino type pattern. We're not suggesting that's going to happen, but just get us to a neutral pattern and get La Nina out of here. Sea surface height data. This also is what feeds that previous model quite a bit. So this is Chile, Peru, the equator right there, Central America, Hawaii there, dateline there, equator there. These are not temperatures, -15, -10. This is sea surface height, the sphere of the ocean. It's 15 centimeters lower than normal, driven by a mixture of stronger than normal easterly trades, but also cold water at depth. Cold water contracts. It'll leave a little divot on the ocean surface. Likewise, over here in the west, warm water at depth expands, it'll create a bump on the ocean surface. And also, if you have strong easterly trades, well, all this water that's being pushed from this direction has to go somewhere, so it all balls up here in the West Pacific. As soon as these easterly trades die and you get a little westerly push here, there'll be like a flood of water, like the tide will rush in going off to the east. But right now, easterly trades, if anything, a little bit stronger than normal, and temperatures a little bit colder than normal, but we think this is probably the last of it. Upper ocean heat anomaly chart. This paints the picture really well. This is over time. West Pacific here, East Pacific here, going back a year in November 2021. Very cold water in the east, warm water in the west. A Kelvin wave made it across around Christmas time last year into the early part of spring, and then cold water erupted again, driven by stronger than normal easterly trades. So we got into May, June, early part of July. Another Kelvin wave tried to make it across the Pacific, and since then, here we go, just colder than normal water. And you can see it actually kind of ballooned a little bit here about a week ago, and it's getting a little bit more entrenched. The hope is that there'll be something like this, only stronger, coming, a Kelvin wave, and easterly trades will die out, and this whole thing will become a lot different with these warm waters starting to migrate into the West Pacific. Once that happens, that's the end of La Nina. Upper ocean heat anomaly chart. This sort of paints the picture pretty well too. The depths of La Nina back in the fall of 2021 into early 2022. Kelvin wave, cold upwelling phase, another Kelvin wave back in July, and then here we are just sitting in not a great position, not as bad as we were here a year ago, but still not great. We want to see these temperatures starting to go up. Sea surface temperatures, the anomalies, difference from normal for this time of year. The classic La Nina signature, the blues colder than normal waters, Chile, Peru, Central America, Mexico, and Hawaii here, the equator right here. The blues, much colder than normal waters, especially right off of Peru, and then being caught by trades, high pressure here in the Gulf of Alaska, just driving upwelling, driving the cold water across the Pacific, both north and south of the equator. And right in here, this lighter blue thing going on here, that seems to be temperatures not as cold as they were. The focus is more in a thin area right here now than a rather more robust signal that we saw months ago. The trend for the past 7 days, the blues showing colder than normal waters. The area we're really interested in is just right on the equator, 5 degrees north and south of the equator. You see, lately, temperatures getting a little bit colder. We think this is the last little pulse of cold water, but maybe there'll be a little bit more coming. And then the backed off view, again, colder temperatures along Peru and out along the equator, but there's this generalized weakening there and in there and down here. The signal just doesn't look as persistent and as dug in as it was months ago or even last year. I think it was even the year before that. We think we might be approaching the end of La Nina, especially with what we know is going on in the atmosphere. Sea surface temperature anomaly. This is just actual water temperatures in the Nino 1.2 region. This is the area right up there along the Ecuador and the Galapagos. Temperatures pretty much hanging. Today's value minus 2.004 degrees centigrade right there. And where have they been the past? Well, 1-2 weeks. Hovering pretty much as low as they've been for a month. Let's see, this is 1, 2, 3, 4, 5, 6 weeks. So as cold as they've been, but this is not unexpected. In the official El Nino monitoring region, the Nino 3.4 region right there, this is the area from south of California on the equator out to about the dateline. Temperatures minus 1.137, 1 and 137 thousandths of a degree below normal right there. So temperatures falling the past 9 days. We don't like that. Again, we think it's maybe the last of easterly anomalies really starting to, make their last stand. But again, just a guess. Either way, if you just look at it on the surface right now, a clear La Nina signal. So what's going on in the atmosphere right now? Not a forecast, not a projection, just dead ground truth. What's happening at the moment? We look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, which is in the Indian Ocean, and Tahiti, which is in the equatorial Pacific. All right, when pressure is lower over Tahiti, the index goes negative. Well, it's positive today at 18.05. It's up to 33.65 2 days ago, and it has been nothing but rock solid positive for a month, suggesting at a minimum the inactive phase of the MJO. We take the noise out of this, we look at the 30-day average, just average it out, the value plus 18.91, and that is, well, not too different than it's been for the month. It's not going up, but it's certainly not going down either. It's deep in La Nina territory. The 90-day average, this is the El Nino La Nina indicator to the value plus 15.34. Again, we want to see these down in negative territory to suggest the active phase of the MJO or El Nino. 15.34, well, we're actually going up from 11.73 a month ago, so not going in the right direction for the moment. Here's the 30-day SOI graphed out. There we are today, somewhere around plus 16, something like that. The downward spikes are the active phase of the MJO. This is neutral right here at 0. We're well above neutral. This is La Nina territory. The last time we were in El Nino-ish territory was back the spring of 2020. And then there has been a steady upward trend since then into La Nina. So this would be July. That's 1 year, 2 years. Starting to work on our third year. Are we going to make it? Well, we're going to find out in a second. Sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. So here's the model. It's pretty much unchanged from that last week, the week before that. This is the raw data, suggests temperatures dropping to about minus 1.25 degrees in mid-November. Remember, we're seeing the SOI go positive. We're seeing negative anomalies. We're seeing everything that suggests the ocean is getting colder. The model says, and has been predicting, yes, it will get colder before it gets warmer, but start about November 15th. That's as cold as it's going to get. So that's only 2 weeks away. And we already know the atmosphere is starting to change, with westerly anomalies starting to push over the far west Pacific. And that, to me, suggests that La Nina is on its last stand. What will happen is sea surface temperatures rise to 1 degree below normal as we get into December, and then the La Nina threshold is half a degree below normal, about mid-February, something like that, and then almost approaching El Nino territory as we get into the summer. Now, this is the raw data. This is probably the more closer to reality look, and it suggests temperatures only dropping maybe 1/10 of a degree, something like that, again in mid-November. Then after that, it's off to the races, upward and onward, with by mid-January temperatures at, we'll say 0.7 of a degree below normal, almost at the threshold. And as the time we get into mid-February, maybe the first week in February, we'll be at the threshold of La Nina, officially in neutral territory, and then heading up from there. This is all the same as it's been for weeks, and that's actually a good thing. It's not coming soon enough. We'd all like it much sooner, but remember, this is the long end of the pole here. The first part is the atmosphere has to change, then the ocean changes behind that. So for right now, the atmosphere, we think, is starting to change over in the far west Pacific. And within the next week or two, westerly anomalies are supposed to be taking over the Kelvin wave generation area. Just basically like what we've been talking about and what the models have been suggesting for months now. That's a really good thing. So you look at the ocean, you look at the temperatures, go, it's cold and it's getting colder. But that all says that the fundamentals that are supporting the strong easterly anomalies, that are creating the upwelling, that are creating the cold water in the East Pacific, the fundamentals that are supporting all that are supposed to completely disintegrate in the next 2 weeks. So we're through the first stage. The westerly anomalies have started. Not very strong, but all the models now are saying they're going to slowly start building in, and in as little as a couple of weeks, fill half the Kelvin wave generation area, and then building from there. And then what will happen is, again, the ocean, it's a big ship. It takes a long time to turn, but if the atmosphere starts turning and the westerly anomalies build, and you start getting some Kelvin waves, then the temperatures on the surface on the equator of the Pacific, they will start turning too. And the models are suggesting that by the time we get to February, so that's about 3 months from now, we'll be back in neutral territory. At that, and even before then, as the westerly anomaly starts pushing across the Pacific, the jet streams should start waking up. So we wouldn't be surprised that even as we get into maybe early to mid-December, we'll start seeing a better storm pattern, maybe a little, I don't know about solid precipitation into California, but maybe we'll get some luck there. But if nothing else, at least the jet stream will wake up and we'll get a better storm track. Fingers crossed. Now, for the immediate future, yeah, there's a gale up in the northern Gulf. North-angled swell coming for Northern California. Hawaii pretty much high and dry right now. High pressure locked right over the dateline region, right like where the models suggest the high pressure bias is. None of this is particularly surprising, but the good news for Hawaii is the first place that's going to start seeing a change as these westerly anomalies start building is the Hawaiian Islands, because they're closest to the West Pacific where the change is going to occur. And then it will slowly and more steadily propagate across the Pacific as we get into the Christmas time frame and beyond. So for the immediate time, not a whole lot going on swell-wise. So do whatever you got to do. But we think as we get deeper into the winter, things are going to make a turn for the much better. All right, if you enjoyed the video, give us a thumbs up. Questions or concerns? I know a lot of the data here is really deep. write us a comment. We'll be happy to reply if you're thinking it 10 other people are. Like and subscribe, ring the bell. You get automatic notifications when the videos are posted, typically on Sunday. Go to stormsurf.com if you don't want to subscribe. The link's available at the top of every page in the website. And other than that, we're going to do it again next week, same time, same channel. Thanks for watching.